Hydroelectric Power, Its Energy and Its Implications by Alex Dabrowski, Nicholas Dewar, and Massimo Fragapane. The table of contents. Within our presentation, we are focusing on three of the aspects: the chemistry, and more focusing on the erosion, the biology, the effects on the environment, the effects on the humans, and the pros of hydroelectric energy, and the physics. And finally, we have our works cited. Chemistry. The construction of a hydroelectric dam can have many effects, and one of them is erosion, because when the water goes by, it has a slightly acidic tint to it since it is at a higher temperature, and that will increase the erosion caused by the water on the surrounding environment. Also, the reservoir, since the way that it's designed, the concentration of many of the pollutants that can be entered into the water will stay either near the top or at the bottom. So the flowing does not have the pollutants in it, therefore, there is a greater concentration. And when there's a greater concentration, that means that there will be a bad effect on the aquatic life. Here are some erosion gifs and a picture. So we have the erosion on the left side of the dirt, which just shows that it'll just erode down. And then on the right, here's a process of it, just showing where the riverbanks are and where the stuff will flow, and where all the carried stones or where the pollutants would be in solution. Biology, the environmental effects. The construction of hydroelectric dams.
The conversion of energy from water is done through what are called hydroelectric dams or reservoirs. These dams are massive structures that are built in moving streams that create lakes or bodies of water on one side of the barrier. The construction of these dams can have negative effects on the environment or the ecosystem of the area that it was built in. These effects include the changing or blocking of natural course of rivers. When a dam is built, it is usually built in a flowing river. The barrier that is put up prevents the river from flowing in its natural direction. This can have negative effects on the animals in the area, which include the fish no longer having access to fresh water that they need to survive. The blocking of rivers also causes flooding, which can hurt the land animals. Flooding. When a dam is built, the water buildup on one side floods the land in the area. This damages the ecosystem because it can flood animals' land, forcing them to relocate or die. This flooding can also destroy forests, which not only forces the animals to leave, but can also affect the food chain in the area because the plants are no longer available as a food source for the animals. Fish can also be killed by the turbine blades. An essential part of the dam is the turbine, which has long, sharp blades. Many fish can be killed by these blades, which can lead to the endangerment of certain species of fish in the lake, which can also have a negative effect on the food chain depending on their position in the food chain. The construction of reservoirs also release methane gas into the air. Although the conversion of hydroelectric energy does not release pollutive gases into the atmosphere, it releases methane, which is a greenhouse gas. When methane is released into the air, it absorbs the sun's heat, causing the atmosphere to heat up. The photograph on the left shows numerous dead fish that were killed from the hydroelectric dam in the photo. The photograph on the right shows an example of a turbine that is put into an hydroelectric dam. You can see how massive it is and how many blades it contains. These blades are one of the many reasons that dams have negative effects, such as extinction on the species of fish and the bodies of water they are built in. Not only does the construction of hydroelectric dams have a negative effect on the environment in the area, it also affects the human population in the surrounding area. Flooding people's homes and farms. Depending on the size of the reservoir, there could be disastrous effects from the flooding. The floods can be big enough to cover people's homes and their farms. This flooding forces people to relocate from their homes. The relocation of many people from one area can cause changes in their lifestyles or their cultural customs, which can affect future generations of their culture. The flooding that has been caused by the construction of hydroelectric dams around the world has forced about 40 to 80 million people to physically relocate. The photograph on the left shows the flooding of farmland. When a farmer's job is to grow produce and their farmland is destroyed, they have nothing left. Farming took up all their time and they must leave now. The photograph on the right depicts the flooding of homes. When a person's home is flooded, they can lose family members or valuable objects to the flood. Sometimes when a house is flooded, the people who live there have nowhere else to go. While there are some environmental drawbacks and negatives to the construction of hydroelectric dams, there are also positives to using hydroelectric energy. Hydroelectric energy is converted from water, which is a clean source of energy. This means that the process of the conversion or the use of energy will not pollute the bodies of water or the atmosphere with harmful gases or pollutants. Hydroelectric energy is produced from a domestic source, which means that each state can produce their own supply of energy. This is a more efficient system as opposed to one governing body that produces energy, then distributes it among the bodies that require it. Because hydroelectric energy is converted from water, it is renewable. This means that it is able to be used more than once, so there will never be a shortage of it. Renewable energy also produces less harmful gas, such as carbon dioxide, than non-renewable energy sources. This means that it is eco-friendly. Hydroelectric energy is also one of the safest forms of energy to work with. This is because it is converted from water compared to fossil fuels, which are converted from geological remains of living organisms, or nuclear energy, which comes from the release of energy from the fusion or fission of a nucleus. This form of energy is extremely dangerous to work with. The photograph on the left shows how an electric dam converts water to energy. It shows what happens as the water enters into the dam, gets sucked up into the generator by the turbines, is converted to energy by the transformer, and transferred through the cables. The photograph on the right also shows how a dam works from a different angle. What's interesting about this photo is in the bottom right corner there is a human being, which shows how massive the dam needs to be in order to work. It also shows how big the blades of the turbine are compared to the human, so you can imagine how big it is compared to a fish and what happens if they swim through it.
So next we have the physics of a hydroelectric dam. Basically, it goes through conservation of energy and goes from potential energy to kinetic energy to mechanical energy to electric energy. So first, for potential energy, one important aspect of potential energy in a hydroelectric dam is the headwater level, which is where the water comes from, and labeled headwater in the picture, and the tailwater level, where the water leaves, which is labeled tailwater in the photo. You can find the height by finding the distance between these two levels. With this, you can derive the equation for power in the system, which is power equals gravity times the water flow rate times the height. Through this equation, you get the power of the hydroelectric dam in watts, and it's the potential energy of the system. Next, you have the kinetic energy. So basically, as the water impacts with the impulse vanes in the turbine, which are the things that move around which create the power in the turbine, a dynamic force exists in order to move the vanes, which is a kinetic energy. This force can be derived as force equals the weight of the water striking the vanes times the relative velocity of the water with respect to the moving vanes over g times 1 minus the coefficient for loss of velocity moving across the vanes times the cosine of the angle of deflection of the jet from its original direction. This velocity, v, in the last equation, can be found by velocity equals capital V, which is the absolute velocity of the water, minus the absolute linear velocity of the vanes or buckets that are in the turbine. Next, we have mechanical energy. Mechanical energy is made in the hydroelectric plant when the water rotates the vanes in the turbine. The amount of power that's created can be seen in the equation. Theoretical horsepower is equal to the flow rate of water times distance between headwater and tailwater, or height, divided by 8.8. And this gives you the mechanical energy output, so it's in horsepower, which is the mechanical unit, while the electrical energy is terms in watts. So to convert this, you'll have to multiply the horsepower by 746 to get the amount of watts created in the system. And lastly, we have electrical energy. So the amount of electrical energy outputted is dependent on the amount of mechanical energy created and the efficiency of the turbine. Basically, efficiency is because the turbine creates heat as it turns around, as it spins, and so about half of the energy that should be created is dispersed. So you can find this using the equation power is equal to 1/2 times the efficiency of the turbine times the density of the water times the area of swept that the blades use, and then by velocity cubed. This is the works cited.